We are going to start now lecture 3 of chapter 11 class 11 mathematics conic sections. In this lecture we will talk about hyperbola. So first of all we are going to talk about the definition of hyperbola. We are saying it is the set of all points in a plane or locus of points, the difference of whose distance from two fixed points in the plane is constant. So we are saying two fixed points are given and we are talking about a point P. This is F1, this point it is F2. We are talking about the distance PF1 and we are talking about the distance PF2, and we are saying that the difference of these two values, it is constant. So we put mod over here. We are saying the difference of their distance that remains constant. So we are interested in all these points. So the locus of these points, they form an hyperbola, and these two fixed points F1 and F2, these are called the foci. The midpoint of the line segment joining the two foci, it is called the center of the hyperbola. So in this given figure we are saying F1 and F2 are the foci of the hyperbola and O is the center. This is F1 and F2, these are the two foci, or we are saying focus, and the midpoint of these two, it is, this is O, this is the center of the hyperbola. Next is axis of the hyperbola. So there are two axes, one is transverse axis. So the line through the foci of the hyperbola is called transverse axis. We are talking about this line, this is transverse axis, and the line through the center and perpendicular to the transverse axis, that is called the conjugate axis of the hyperbola. Next term we have, it is vertex of the hyperbola. So we are saying vertex is the point where the hyperbola intersects with the transverse axis. So the transverse axis we have over here, the focus, they are lying on the x-axis, and the points where this hyperbola is intersecting, these are the 2 points A and B, these are the vertices. These 2 points, these are the vertices of the hyperbola, and the distance between these two vertices, it is called the length of the transverse axis. So if we are saying that this vertex A, it is at the point minus a comma 0, and this point B, it is at the point a comma 0. So we are considering that the length of the transverse axis as 2a, and the distance between two foci, we are saying this focus, it is minus c0, this is c0, so it is 2 times c, and length of the conjugate axis, it is calculated by using the formula. We are saying length of the conjugate axis, it is b 2b, and it is b is calculated by using the formula b square is equal to c square minus a square, where 2b, it is the length of the conjugate axis. The next term we have, it is eccentricity of the hyperbola. Eccentricity, we know it is equal to the ratio c by a, and clearly in this case the focus, the distance of the focus from the origin is greater than the distance of the vertex. So clearly this value is greater than 1. In case of ellipse, this value was lying between 0 and 1, and in case of hyperbola, this value is greater than 1. So we are saying eccentricity is greater than 1. The formula, it is same, it is c by a. It is a constant value for a given hyperbola. Next we have a standard equation of a hyperbola. So we have to prove that the standard equation of the hyperbola is x square over a square minus y square over b square is equal to 1. So we are saying the proof is similar what we have done in our previous lectures. We are saying, suppose we have an hyperbola and this o x dash ox and y dash oy, these are the transverse and the conjugate axis of the hyperbola. O is the center, this O, we are saying this point, it is 0 0, this is the center, and the focus we have, it is f1 and f2, their coordinates, they are minus c0 and c0, and the vertices we have, these are the vertices A and transverse. On the transverse axis we have vertices, this point it is a comma 0 and minus a comma 0, and this point it is a comma 0. We are talking about any point pxy. We want to find the locus of the points. We are talking about the point pxy, and we know that the difference of their distance from the focus of this point pxy from the focus, it should be a constant. So we are writing that the distance of this point p, we are writing it is pf1 minus pf2, that should be equal to, suppose I am considering another point a over here. I am talking about this point a on this hyperbola. So what we will have over here, that a f2 minus af1, we are talking about this distance. So what is af2? We are talking about this distance af2, and we are subtracting from it the distance af1. We are saying these two distances, these are equal. So basically we are talking about the distance between these two, it is the length of the transverse axis, that is 2a. So we are writing that this value should be equal to 2a. So now the distance pf1, when we are talking about, that distance is square root of x minus, this is plus c square plus y square, then it is minus the distance pf2, it is square root of x minus c square plus y square, and that value should be equal to 2a. So we can write it in the form square root of x plus c square plus y square is equal to 2a plus square root of x minus c square plus y square. So if we square both sides of this equation, these calculations, these are shown over here. If we square both sides of this equation and adjust the terms, we obtain the equation in the form, we are writing the equation in the form, you can look at these calculations. It is x square over a square minus y square over c square minus a square is equal to 1. And the value of c square minus a square, we know it is equal to b square. So we are writing that the equation we have, it is x square over a square minus y square over b square is equal to 1. So this is the standard equation of the hyperbola. For the converse part, we consider that there is a curve whose equation is x square over a square plus minus y square over b square is equal to 1, and we have to prove that this is the equation, this curve, it is a hyperbola. So for any point pxy on this curve, we are writing the value of y square, that is equal to b square into x square over a square minus 1. We can write this is equal to b square into x square minus a square over a square. Now if we calculate the distance pf1, its value is square root of x plus c square plus y square. Now if we substitute this value of y square over here, this is the value of y square we have, we substitute this value over here, we obtain this value is equal to square root of x plus c square plus b square into x square minus a square over a square. Now if we simplify this term, these calculations, these are shown over here, we have simplified these terms, and the answer we obtain, it is cx over a plus a. By simplifying this term, we are getting the answer in this form. And similarly we can prove that pf2 distance, that is equal to cx over a minus a. We have obtained pf1 is equal to cx over a plus a. Now we have to calculate the difference of these two terms. So difference of these two terms means we are talking about it is pf1 minus pf2. We are calculating it is cx over a plus a minus cx over a minus a, and the value comes out to be equal to 2a. So we are saying that we have considered any curve is there, any point p, it is satisfying pxy, this point pxy is there. We are talking about 2 points f1 and f2. We are saying that difference of their distance, that is equal to a constant value. The difference of the distance of this point pxy from two fixed point, it is a constant value, and this is the definition of the hyperbola. and hence we are saying that this locus pxy, it represents an hyperbola. So we have considered a particular case over here. We are saying if a is equal to b, then we obtain the equation in the form, x square minus y square is equal to a square. This hyperbola, this particular case of hyperbola we are talking about, a is equal to b, the hyperbola comes in this form. This is known as equilateral hyperbola. This hyperbola is called equilateral hyperbola. Next we have is the latus rectum of an hyperbola. So we are saying the latus rectum, it is a line segment perpendicular to the transverse axis and through any of the foci with endpoints lying on the hyperbola. This is just a similar definition as we have for the case of parabola and the ellipse. So these are shown over here. We are saying these are the lines perpendicular to the transverse axis and passing through the focus, and their endpoints, they lie on the hyperbola. So we have to calculate the length of the latus rectum for the hyperbola with the equation x square over a square minus y square over b square is equal to 1. So suppose we are saying the focus of this hyperbola, they are f1. The coordinates of f1 we are writing it is minus c comma 0, and another it is f2, this is c comma 0. These are the two foci, where we know that the value of c square is equal to a square plus b square, and we are calculating the length of this latus rectum, and we are considering that this length we have it is L. Then the coordinates of this point P, it is c comma L, and this point c comma L, it should lie on this hyperbola. It means it will satisfy c square over a square minus L square over b square is equal to 1. From this we can calculate the value of L square is equal to b square into c square over a square minus 1. And on solving this value, we obtain L square is equal to b raised to the power 4 over a square. So this implies us L is equal to b square over a, and the length of latus rectum, we are saying length of latus rectum, that will be equal to 2 times L, that is equal to 2b square over a. So this is the length of latus rectum. So we have listed all the results related to hyperbola on this slide. So we are saying we are talking about the horizontal hyperbola. Horizontal hyperbola means the transverse axis, it is the x-axis. So the standard equation for this, it is x square over a square minus y square over b square is equal to 1. The center of this hyperbola, it is 0, 0. The transverse axis we have, the focus, they are minus c0 and c0. So the transverse axis corresponding to this hyperbola, it is x dash ox, and the conjugate axis, it is y dash oy. It is perpendicular to the transverse axis and passing through the center O. The focus of this hyperbola, they are given by this f1 and f2. These are the focus. Foci we are saying it is minus c0, c0, or you can write it is minus ae or ae, where e is the eccentricity, and the eccentricity, it is given by this formula. It is e is equal to c by a, or we can write it as square root of a square plus b square by a. The vertices of this hyperbola, they are points on the transverse axis where this hyperbola meets the transverse axis. So these are the points a and b. Their coordinates, they are minus a0 and a0. Length of the transverse axis, it is 2a, and the equation is y is equal to 0. Length of the conjugate axis is 2b, and its equation is x is equal to 0. And length of the latus rectum, we are talking about this line over here. The length of this latus rectum, it is 2b square over a. So these are some results related to horizontal hyperbola. And similarly, we can obtain the results related to the vertical hyperbola. Vertical hyperbola means we are talking about the transverse axis, it is now the y-axis. This is the vertical hyperbola. The center, it is O. This is center O. The equation is y square over a square minus x square over b square is equal to 1. Now this is the equation for the vertical hyperbola, and the axes they are clear that the conjugate axis this is the y axis, and the transverse axis it is the y axis, and conjugate axis it is x axis. Now the foci we have, it is 0 comma minus c and 0 comma c. These are the two foci we have, and the vertices they are now lying on the y axis. These are 0 comma a and 0 comma minus a. Eccentricity, the formula is same, it is c over a. The length of transverse axis and their equations they are 2a is the length, and the equation is x is equal to 0, and length of conjugate axis it is 2b, and this equation is y is equal to 0, and length of latus rectum it is 2b square over a. So these are some results related to the vertical hyperbola, and if you want to derive these results, you can derive them on the same lines as we have derived the results for the horizontal hyperbola. Next we are going to solve certain problems based upon this. So first is find the length of the axis, coordinates of the vertices and foci, the eccentricity, length of latus rectum corresponding to the hyperbola given by this equation. So when we compare it with the standard equation, it is x square over a square minus y square over b square is equal to 1. So clearly this is a horizontal hyperbola, where the value of a it is 6, value of b it is 8, and using these two values we can calculate the value of c is equal to square root of a square plus b square, and the answer we get it is 36 plus 6400. So the value we obtain for c it is 10 units. So when we are talking about the length of the hyperbola, it is 2a, that is equal to 12 units. This is length of the transverse axis. When we are talking about the length of the conjugate axis, it is 2b, that is equal to 16 units. Then we are talking about the vertices. We are saying the hyperbola we are having it is of this form. This point it is 0 0, this is the center. Then we have calculated the value of c, so this gives us minus 10 0 and 10 0. These are the focus. When we are talking about the vertex, it lies on x axis, so the values we have it is minus 6 0 and 6 comma 0. So these are the two vertices. We have calculated lengths of the transverse and the conjugate axis. We have seen the two focus. Then we have to calculate is the eccentricity. So eccentricity E it is given by the formula c by a. So answer we get it is 10 by 6, that is equal to 5 by 3. Clearly this is a dimensionless quantity. And last thing we have to calculate is the length of latus rectum. It is 2l is equal to 2b square over a. So the answer we obtain it is 64, and a it is 6. So answer we get it is 64 by 3. So this is the length of the latus rectum. In this next question, we have to find the length of the axis, coordinate of the vertices, foci, eccentricity, length of latus rectum corresponding to the hyperbola, whose equation is 9x square minus 16y square is 144. So we write this in the standard form. We divide the equation with 144 and we get it is x square over 16 minus y square over 9 is equal to 1. So we obtain the value of a equal to 4 and value of b is equal to 3. So from this we obtain the value of c is equal to a square plus b square, and the value we obtain it is 5. Now we have to calculate the length of the axis. So first thing we have to calculate is length of the axis. So length of the transverse axis it is 8. The length of the conjugate axis it is 6. Next we have to calculate the coordinate of the vertices. So this is a horizontal hyperbola. So coordinate of the vertices we obtain from this, it is minus 4 comma 0 and 0 comma 4 comma 0. They lie on the x axis. Next we have to calculate is the foci. So the two focus that we have, they are given by this value c. The value of c we have it is 5, so it is given by minus 5 comma 0. Again they will lie on the x axis, and 5 comma 0. These are the two focus. Then we have to calculate the eccentricity. So eccentricity E, it is given by the formula C by A. So the value we obtained is 5 by 4. And last thing we have to calculate is the length of the latus rectum. It is 2L is equal to 2B square over A, and the answer we get, the value of A we have, it is 4. So the answer we get, it is 9 by 2 units. So when we are writing the lengths, we are writing units over here. When we are talking about the eccentricity, it is dimensionless quantity, it is just a ratio. Next is find the equation of the hyperbola whose vertices are plus minus 2 0 and focus they are given by plus minus 3 0. So the vertices, they are lying on the x-axis. It means we are talking about the horizontal hyperbola. So we are interested in an equation of the form x square over a square minus y square over b square is equal to 1, where the value of a, it is 2, and the value of c, the focus is given, it is 3. So from these two equations we can calculate the value of b square is equal to c square minus a square. So we are writing this is equal to 5. So the value of a square we have equal to 4. So substituting both these values, a square and b square, in the given equation, we obtain the required equation as x square over 4 minus y square over 5 is equal to 1. So this is the required equation of the hyperbola. Next is find the equation of the hyperbola whose foci are given by plus minus 5 0 and transverse axis is of length 8. So transverse length of transverse axis means we are given 2a is equal to 8. Clearly it is a horizontal hyperbola because the focus they are lying on the x-axis, and the value of c is given to be 5. So this implies us that the value of a we have, it is 4. From these two values we can calculate the value of b square is equal to c square minus a square. So we get the value is equal to 9. So we have a square is equal to 4, b square is equal to 9, and the equation we know it is x square over a square is 16. This is a is 4, so a square is 16. So we are writing x square over 16 minus y square over 9, that is equal to 1. So this is the required equation of the hyperbola. The next question we have is find the equation of the hyperbola whose foci are plus minus 4 0. Clearly it is a horizontal hyperbola, and this is the value of c is 4, and length of the latus rectum is 12 units. So length of the latus rectum means the value of 2l, that is equal to we are saying it is 2b square by a is given to be 12 units. So from this value we can write c square is equal to 16, and this value is equal to a square plus b square, and from this equation we obtain b square is equal to 6 times a. If we substitute this value over here, we get the value of a is equal to, or we are writing a square is equal to 16 minus 6a. So this is a quadratic equation, and we can write a plus 8 into a minus 2 is equal to 0. So we are obtaining two values of a. One is a is equal to 8, and one is minus 8, and one is a is equal to 2. So we are less interested in this value a is equal to minus 8 because we know that this a basically it represents the length. So we are interested in the positive values. We are writing a is equal to 2, and the value of b we obtain corresponding to it is 6 into 2. B square we are talking about, it is 6 into 2, it is 12. So a square we have, that is equal to 4. So combining both these values we get the equation of the hyperbola as x square over 4 minus y square over 12, that is equal to 1. So this is the required equation of the hyperbola. Next is find the equation of the hyperbola whose vertices, again it is a horizontal hyperbola, these are the vertices. It means the value of a, it is 7, and eccentricity e, that is equal to c by a, that is given to be equal to 4 by 3. So from this result we can see we are talking about c square is equal to a square plus b square. From this result we can calculate the value of c to be 28 by 3. So the value of b square we have it is 28 by 3 square minus 49, and the answer we obtain that is equal to 343 by 9. So the value of a square we have it is 49, value of b square we have it is 343 by 9. So the equation of the hyperbola, it is horizontal hyperbola, it is x square by 49 minus 9 by 343 y square is equal to 1. So if we take the LCM over here, this equation becomes 7x square minus 9y square is equal to 343. So this is the required equation of the hyperbola. Next question we have is find the equation of the hyperbola whose eccentricity E is given to be 3 by 2, that is equal to c by a, and focus is given to be plus minus 2, so the value of c is equal to 2. It is horizontal hyperbola. So from this we can obtain the value of a is equal to c by e, so we obtain it is 4 by 3. Now the value of b we know, it is b square is equal to c square minus a square, so that is equal to 4 minus 16 by 9, so answer we obtain it is 20 by 9. So we are getting a square is equal to 16 by 9 and b square is equal to, we have obtained the value of b square and a square, so the equation becomes x square over a square, that is 16 by 9, minus y square over b square, that is 20 by 9 is equal to 1. So this implies us that 45 x square minus 36 y square equal to 80. So this is the required equation of the hyperbola. Now next we have is find the lengths of the axis, the coordinates of the vertices and the foci, the eccentricity, length of latus rectum corresponding to this hyperbola. If we compare it with the standard equation, it is y square over a square minus x square over b square is equal to 1. So this is a vertical hyperbola. So the value of a we obtain, a square we have it is 4, value of b square we have it is 9. So this implies us a is equal to 2 and this implies us b is equal to 3. So the value of c square we have it is square root of a square plus b square, it is equal to square root of 13. This is value of c, not c square, it is value of c. So first thing we have to calculate is length of axis. So transverse axis, in this case it is y axis and the length of that is 2a is equal to 4, and the conjugate axis, the length of conjugate axis it is 2b, so that is equal to 6 units. Next we have to calculate the coordinate of the vertices. So vertices will lie on the y axis, so the coordinates of the vertices, they will be 0 comma a, that is equal to minus 2, and second is 0 comma 2. Next we have to calculate is the focus, to focus. So the coordinates will be minus 0 comma minus root 13 and 0 comma root 13. These are the two focus that we have. And then we have eccentricity. E we know the formula is c by a, so that is equal to root 13 by 2. And last we have to calculate is the length of latus rectum, so that is 2l is equal to 2b square over a, and that value comes out to be 9 units. So these are the required values corresponding to this hyperbola. Next is find the length of the axis, the coordinates of the vertices and foci, the eccentricity, the length of latus rectum of the hyperbola y square minus 16x square is equal to 16. So we write it in the standard form. We get it is y square by 16 minus x square is equal to 1. So the value of a square we have it is equal to 16 and the value of b square we have it is 1. Clearly this is a vertical hyperbola. So the value of a we obtain it is 4, the value of b we have it is 1. So the value of c we have it is square root of 16 plus 1, that is equal to root 17. Now we have to find the length of the axis. So axis, this is the vertical parabola, so transverse axis, its length is 2a, that is equal to 8 units, and conjugate axis, its length is 2b, that is equal to 2 units. Next we have to calculate is the coordinates of the vertices. Again the vertices will lie on the y axis, so the coordinates will be 0 comma minus 4 and 0 comma 4. Next we have to calculate is the foci. So that will also lie on the y-axis. So the coordinates will be 0 comma minus root 17 and 0 comma square root of 17. Next we have to calculate is the eccentricity. So E is equal to C by A. So that value comes out to be root 17 by 4. And last we have to calculate is the length of the lattice rectum. It is 2L is equal to 2B square over A. And the answer we obtain, that is equal to 1 by 2 units. So these are the required values corresponding to this hyperbola. Next we have is find the equation of the hyperbola whose vertices are 0 comma plus minus 3 and foci they are 0 comma plus minus 5. So clearly this is a vertical hyperbola, and corresponding to these vertices we get the value of A is equal to 3, the value of C we obtain it is 5. So value of B square we will have it is C square minus A square, that is equal to 25 minus 9, that is equal to 16. And from this the value of A square we have, that is equal to 9. And the equation of the vertical hyperbola we know it is y square over A square minus x square over B square is equal to 1. So substituting the value of A square and B square in this equation, we get it is y square over 9 minus x square over 16 is equal to 1. So this is the required equation of the hyperbola. Next is find the equation of the hyperbola whose eccentricity is 5 by 3, that is E is equal to C by A, that is equal to 5 by 3, and whose vertices are 0 comma plus minus 6. So again this is a vertical hyperbola, so the coordinates of A it is 6. The standard form we will have it is y square over A square minus x square over B square is equal to 1. Now we have to calculate the value of B. So this implies us the value of C we have it is 10. We have substituted value of A over here. Using both these values we obtain B square is equal to C square minus A square. So the value of B square we obtain, this is equal to 100 minus 36, that is 64. And the value of A square we have, the value of A square we have it is 36. Value of B square we have it is 64. So the equation we will obtain it is y square over 36 minus x square over 64 is equal to 1. So this is the required equation of the hyperbola. Next we have to find the coordinates of its foci. So coordinates of its foci, the value of C we have, and from this value we can write that the focus that will lie on y-axis, that will be plus minus 0 comma plus minus 10. So these are the coordinates of the foci. Next is find the equation of the hyperbola whose foci are 0 comma plus minus 12. So it is a vertical hyperbola. Equation is y square over A square minus x square over B square is equal to 1. Focus is given, it is C is equal to 12, and the length of the lattice rectum, that is 2L is equal to 2B square over A, that is given to be equal to 36. So this implies us that B square is equal to 18A, and we know that the relation between C square, A square and B square. Now we have the value of C square, it is 144, that is equal to A square plus 18A. The value of B square is 18A. So solving this value we obtain, this is A plus 24, the quadratic equation. We split the middle term and we obtain A minus 6 is equal to 0. So we are getting A is equal to minus 24 or 6. We are not interested in the negative values of A. So we are writing the value of A we have it is 6. This implies us A square is equal to 36. The value of B square we have it is 18 times A. It comes out to be 108. So the required equation, we obtain it is y square over A square minus x square over B square is equal to 1. So this is the required equation of the hyperbola. Next is find the equation of the hyperbola with center at the origin and length of the transverse axis at 6, and the focus at 0, 4. So this tells us that we are talking about a vertical hyperbola. The value of c is given to be 4. Length of transverse axis is 6, and this implies us that the value of a we have it is 3, and the equation of the hyperbola it is y square over a square minus x square over b square is equal to 1. This is a vertical hyperbola. The value of b square we obtain, that is equal to c square minus a square. So we are getting it is 16 minus 9 is equal to 7. So the value of a square we have it is 9. The value of b square we have it is 7. So substituting these values in this equation, we obtain the equation as y square over 9 minus x square over 7, that is equal to 1. So this is the required equation of the hyperbola. Next is find the equation of the hyperbola whose foci are 0, plus minus 6 and length of whose conjugate is 2 root 11. So again, from this it is clear that we are talking about a vertical hyperbola. It is y square over a square minus x square over b square is equal to 1. The value of c is given to be 6, and length of the conjugate axis means the value of 2b is given to be 2 root 11. So the value of b is square root 11 and b square it is 11. Now we know that a square is equal to c square minus b square. So we get it is 36 minus 11, that is equal to 25. So we obtain a square is equal to 25, b square is equal to 11. So the required equation becomes, this equation will become y square over 25 minus x square over 11 is equal to 1. So this is the required equation of the hyperbola. Next is find the equation of the hyperbola whose foci are 0, plus minus root 10. So we are, from this we can obtain that the value of c we have, that is equal to square root 10. The equation we have it is y square over a square minus x square over b square is equal to 1, and it passes through the point 2, 3. It means this point will satisfy this equation. So we obtain that when we substitute this value over here, we obtain 9 over a square minus 4 over b square is equal to 1. The value of c we have it is square root of 10, and the relation we know it is c square is equal to a square plus b square. So we obtain 10 is equal to a square plus b square. So the value of b square we obtain it is 10 minus a square, and if we substitute this value over here, we obtain it is 9 over a square minus 4 over 10 minus a square is equal to 1. If we take the LCM over here, we get it is 90 minus 9a square minus 4a square, that is equal to 10 minus a square into a square. And solving this quadratic equation, we obtain this is a raised to the power 4 minus 23a square plus 90 is equal to 0. So we obtain from this two values of a square. We are getting a square is equal to 18 or a square is equal to 5. These calculations, these are shown over here. You can look at these calculations. This is the equation we are obtaining, and we are getting two values of a square. Now if we substitute these values of a square in this equation, so we are saying for a square is equal to 18, we get b square is equal to minus 8, and this thing is not possible. So we are not interested in the value a square is equal to 18. If we substitute a square is equal to 5, we get b square is equal to 5. So these are the required values of a square and b square. Now if we substitute these values in this equation, we obtain the final answer in the form, it is y square over 5 minus x square over 5, that is equal to 1. So the required equation of the hyperbola we have it is y square minus x square is equal to 5. So this is the equation of the hyperbola which has focus at the point 0, root 10 and which passes through the point 2, 3.